Hi. Today we will continue with lesson 14.
Hello, Assalamualaikum student. We are going to continue our lesson 14, the comparison between elastic and plastic deformation of a wire. So the first point, for elastic deformation, extension does not exceed the elastic limit of the material, but for plastic deformation, extension exceeds the elastic limit of the material. Look at the graph stress against strain. So point A is a proportionality limit and point B is elastic limit. So the elastic deformation not exceed the elastic limit. But for plastic deformation, the extension will exceed the elastic limit. And the second point, when stretching force is removed, the wire return to its original length. But for plastic deformation, when stretching force is removed, the wire does not return to its original length. The wire is permanently length. And the third one is for elastic deformation, it obeys Hooke's law, but the plastic deformation does not obey Hooke's law. Okay, what is Hooke's law says that? Hooke's law says that force is proportional to extension. So we look at the graph, force against extension. This is extension and the force. So the straight line graph shows the elastic deformation and the force is directly proportional to the extension, the straight line graph. So F is equals to kx. X is the elastic constant. Okay, but the plastic deformation does not obey the Hooke's law.
Okay, now we continue with the fourth point.
The fourth point is for elastic deformation does not change the internal structure of a wire, and for plastic deformation can change the internal structure of a wire. And the last one, for elastic deformation, when Hooke's law is obeyed, the energy stored during elastic deformation is fully recovered when the force is removed. But for plastic deformation, during plastic deformation, energy is converted into heat.
We continue discussion about the definition of brittleness and ductility.
What is the difference between ductility and the brittleness? So, for the ductile materials, undergo plastic deformation before breaking. So, I will explain these two material properties with the help of the stress against strain graph. So, for the ductile materials, the material will undergo, this one is graph stress against strain. So we undergoes the elastic deformation and the plastic deformation before it break. So such as for example, such as steel, copper, aluminium, gold. So we know that this is a proportionality limit, this is a elastic limit. So the ductile material will undergoes the plastic deformation. But for brittle materials, do not show plastic behavior deformation. So from the graph, stress against strain, stress, after reaching the elastic limit, this one is like elastic limit. The material will break, such as glass and others.
Next, information on stress against strain graph for various material. Keep watching.
The stress strain graph for various material. So for example, glass is brittle material because it will break just after elastic limit is reached, and the ductile material will undergo plastic deformation For example, steel, copper, and aluminium. Brittle does not show much deformation, but for ductile material will deform more and more because energy is more stored in the metal.
Thank you for your attention. Bye.